In the world of industrial applications, material strength and durability are paramount. Choosing the right hardening method is critical. The wrong choice can lead to catastrophic component failure, impacting performance, safety, and cost. Today, we delve into two fundamental heat treatment processes, case hardening and through hardening. Understanding their differences is key for engineers, metallurgists, and students alike. We'll explore their applications, benefits, and how to select the optimal method for your specific needs. Choosing the wrong hardening method can destroy your component. Here's the real industry answer. Material strength and durability are the backbone of any reliable industrial component. Component failure, often due to incorrect heat treatment, can lead to costly downtime and safety hazards. Selecting the appropriate heat treatment is not just a preference. It's a critical engineering decision. Let's begin with case hardening, a process designed to create a hard wear-resistant surface while maintaining a tough ductile core. This is achieved by diffusing carbon or nitrogen into the surface of a low-carbon steel component. The result is a component with excellent surface hardness, ideal for resisting wear and abrasion. Common methods include carburizing, where carbon is added to the surface, which involves diffusing nitrogen into the surface, and carbonate riding, a combination of both carbon and nitrogen diffusion. Now, let's turn our attention to through hardening, a process that hardens the entire cross-section of a component. This method is typically applied to medium or high-carbon steels, ensuring uniform hardness throughout the material. The goal is to achieve maximum strength and toughness across the entire part, not just the surface. Key steps include quenching, rapid cooling to achieve a hard microstructure, followed by tempering, which reduces brittleness and increases toughness. The resulting microstructure is often martensite, known for its high strength. Let's compare these two methods side by side to highlight their fundamental differences. Case hardening provides a hard surface with a ductile core, while through hardening offers uniform hardness throughout. The depth of hardness is shallow for case hardening, but extends through the entire component for through hardening. Case hardening retains a tough core, whereas through hardening aims for overall strength and toughness. Understanding these distinctions is crucial for selecting the right process for your application. So, when should you use each method? Let's look at some real-world examples. Case hardening is ideal for components requiring high wear resistance and fatigue strength. Think of gears, camshafts, and cutting tools, where surface durability is paramount. These parts benefit from a hard exterior to resist abrasion, while the softer core prevents brittle fracture. Through hardening is best suited for components that need uniform strength and toughness throughout. Examples include heavy-duty shafts, high-strength fasteners, and structural components. These parts are subjected to high stresses and require consistent mechanical properties across their entire volume. Beyond application, cost versus performance is a significant factor in decision-making. Case hardening processes can sometimes be more complex and costly due to the precise control required for surface diffusion. However, the extended component lifespan and superior wear resistance often justify the initial investment. Through hardening, while potentially simpler in process, requires higher alloy content steels, which can increase material costs. Its performance benefits lie in overall structural integrity and resistance to bulk deformation. A common mistake is using case hardening for components that require deep uniform strength. This can lead to core failure despite a hard surface. Conversely, using through hardening for parts needing only surface wear resistance can be overkill and uneconomical. The key is to match the hardening process to the specific demands of the application. Consider material properties, expected loads, and environmental factors. In conclusion, both case hardening and through hardening are invaluable tools in metallurgy. Their effective application hinges on a deep understanding of their unique characteristics and benefits. By making informed decisions, you can ensure the longevity and reliability of your industrial components. Thank you for watching. We hope this comparison helps you in your engineering endeavors. Subscribe for real-world heat treatment knowledge from 20 years of industry experience.